Hi, my name's Andrew Tiernan, and I'm re-recording this for the third time, trying to fix some audio stuff with my PC, because apparently when I submitted my assignment last week, it did not have any audio on it. So my assignment for week one, uh, Introduction to Ammunition and Basic Ballistics for FTT 122. And the first part of that assignment was articulating my understanding of 4 steps of ballistics. And with that, talking about different variables that can affect the flight and performance of a projectile. And the first step, or the first portion of ballistics, would be internal. And that's how a cartridge interacts with the firearm and the firearm's design. And that can have anything to do with seating depth of the cartridge, the chamber design, or whether it's bolt action, gas operated, if we're dealing with a revolver and have a revolving chamber system, a cylinder. So that all plays into that internal ballistics and how that bullet's going to interact with the firearm. And that can also deal with the makeup of the metals and the chamber ability to take a certain pressure load. The second step of ballistics, and on the way from internal to transitional, we talk about things like the muzzle twist or the barrel twists ratio with a rifled barrel. And this is going to directly start affecting that bullet's flight for when it gets out of the muzzle. Transitional is when it leaves the muzzle, talking about things like the velocity when it leaves the muzzle, as well as where does the gas go? Does it come directly behind the bullet, or is there some type of muzzle flash device or flash suppressor that redirects that gas? That can all affect the transitional ballistics as it leaves the muzzle, as well as if you're using a can or a silencer, how does that affect the flight of that projectile once it leaves that muzzle? And then we move right into external ballistics, which would be things like the BC play into that, the shape of a bullet, and with the BC we talk about G1 versus G7, the bullet design. Is it boat tail? Is it rebate? Is it a plain old, like a G1 type projectile, that shape of that projectile, and how it's going to fly through the air, and the trajectory of that, okay? And that also, I'll get into sectional density, but that plays into that as well, because we're talking about the mass as it's moving through the air with the design of that, the twisting rotation, just like we're throwing a football, and as well as the mass moving through the air and all the resistance it hits from the outside environment, whether it be wind, air, just straight up air resistance, because that does get thick, the humidity level, things like that. Going into a shaded area, out of sunlight, those little things play into the whole external ballistics. And that's why we do things like a dope chart, data obtained on previous engagement. The last portion of ballistics is terminal ballistics, and that's how that bullet or that projectile is going to interact with the target. Is it a hard target, soft target? And bullet design is definitely going to play into that. What kind of core do we have? Is it a lock core? What kind of jacket do we have? Is it, and even the boat tail, even the construction all the way back to the boat tail is going to play a key role in that. But one of the things that plays a real big role in that is something called sectional density, moving into part 2 of this assignment. And sectional density is how thick that bullet is. Really easy to compute using the caliber and how much that bullet weighs. That's going to tell us what that sectional density is going to be, okay? So that is a very important piece of all the ballistics, because that's how that bullet's going to interact throughout every single one of those 4 steps. Why is sectional density more important than the projectile shape? Well, the book says so. That's an easy answer, right? No, it actually does make sense that it does, because when you look at energy, that equals mass times acceleration squared. The shape can play a role into how fast the bullet's going to move, yes, but other things play into that, like our powder load, how many twists we have in the rifling. Other things are going to play into that more than just shape. But that mass of that bullet, that sectional density and how thick that bullet is going to play the most huge role. As an external source, I used Applied Ballistics for Long Range Shooting, done by Brian Litz, 3rd edition. Thank you and have a great night.